So in this module, we're going to be looking at what we call conditional statements. Typically, in a lot of languages, you'll see it listed as an if or maybe an if-then statement. And basically what we're doing is we're checking to see if some condition is met, then we're going to do some action or actions. Now, we're also going to look at the if-then-else construct, which means what happens if our condition is not met? Do we want to do something special in that case? As well as an additional data type, the Boolean data type, and some Boolean logic operators. So let's go ahead and get started with that. So I'm going to come in here to Visual Studio Code, and I'm going to create a new file. I'm going to choose a Python file, and I'm going to go ahead and save this. I'm going to call this sample 02 because we're in that second module for Python. So anytime we're going to do a conditional statement, we need to check a variable against another variable or value. This is very typically how we're going to do this. So I'm going to create a variable called age, and I'm going to use an integer data type, and I'm going to set it to be 14 for right now. I'm going to come down and give myself a little bit of visual break. Notice I've given an extra blank line, and now I'm going to write my if statement. And an if statement inside of Python is very simple. It's if, and notice that Visual Studio Code has actually changed the color of the word if. That's because it's a built-in command to Python, and so it's highlighting in a different color. And then we're going to specify our variable that we're going to test, and we're going to say greater than or equal to 16. Notice that we're doing a greater than or equal to. This is one of our 6 standard conditional operators. We have less than or equal to, greater than or equal to, and not equal to. Right now we're doing greater than or equal to. You'll notice I still have a little underline that's showing that there's an error. To end this, I need to put a colon. Now, I like to put a blank space after the variable that I'm testing. I think it makes it a little bit easier for me to read. I still have that error though. You might say, well, what is it for? Well, it's because we haven't given it a body of what to do. So I'm going to hit the enter key, and notice, if you would, that you are indented. So in some languages, you have to enclose things in braces or do something else. In Python, it uses indentation to determine if you're part of a block that is a part of something like an if statement. Okay, so anything that's indented is going to happen if that condition is true. So I'm just going to do something simple like put a print your whole. Okay, that's all we're going to do. Very, very simple, very, very easy for us to do. I'm going to save this, run it. And if you run it, you might go, well, wait a second, nothing printed out in my little terminal window. Did it really run? Was there an error? Well, what happened is, notice that on line 1, we specify age is equal to 14. However, on line 3, we say age is greater than or equal to 16. So if we replace the value that we set age to be, so 14, is 14 greater than or equal to 16? No, it's not. And so it says, well, this wasn't true. This condition was not met. And so I'm going to skip it. So let's change this real quick. We'll set it's equal to 18. Run this one more time. And look, now because age is equal to 18, you are old enough to get your driver's license. Okay, so it was a real simple change. The first time our condition was not met. And that's often referred to as a Boolean false, or a conditional false. In computers, we use either true or false statements. And all of our conditions, everything we put inside an if statement, has to meet this true or false. So I can specify, for example, is an age less than a value? Is it greater than a value? Is it equal to a value? But I can't say, are you approximately... Okay, I can't say, are you a teenager? Are you an adult? It's looking for specific values. So in this case, we can specify, in this example, we see this where we can say, hey, are you greater than or equal to 16? There's a whole large set of numbers that are greater than or equal to 16. So we can get a range, but we have to specify, we have to identify what that range is. So that's an example real quickly of an if statement. Let's take a look at another example. And I'm going to take this exact same example, except I'm going to have 18 be a string. Save it, run, and notice that we get an error. Python doesn't understand how to convert between a string and an integer. So anytime that we're going to have a test, we need to be using the right data types. This is very important if we get input from the end user. So if I use that input command, remember I always get a string by default, and I'll have to convert it to either an int or a float if I want to test it against a number. So this is a common mistake, and it's a real simple fix on how you can do that. Now I can do this actually inside of my if statement. I can specify int and take my age and convert it into an integer. Now if I do this, save and run, notice that it says, oh, I have a string. I can convert that string into an integer, and then I'm going to test that integer against another integer. So a quick way to look for a potential problem and see how to solve it. Remember, this is all about how we build upon previous things that we've done. And understanding these conditional operations are very important. We're actually going to see how we're going to use conditions in future modules as well. But let's go ahead and keep looking at some of these examples. In my terminal, I'm going to clear that out, and I'm going to clear out my file just so we have a nice blank start. I'm going to specify first name equals Bob. Now I want to do a quick test, and so let's take another one and say if first name, I'm going to specify equals equals. So if I want to check for equality, I use two equal signs. This is very important for when I'm going to do my test for equality. If I have one equal sign, it means I'm assigning a value. I assign what's on the right-hand side to the left. Two equal signs means that I am putting a test to see, are these two values the same? And so I'm going to say if first name equals equals, and I'll specify Bob. And if so, we're going to do a nice simple little print. I'm going to save this. We're going to run. And notice that it says, oh, Bob. Yes, that's equal to Bob. And now we can print out that statement. But let me show you an example where we're going to have a problem with this. Robert. Now, you may know that Bob is a commonly used shortened version of Robert. In fact, Robert has a couple. They might go by Bob, they might go by Rob, they might go Robert. So even though Bob is a commonly used shorter version of Robert, Python doesn't see it that way. It's looking for an exact match. So if I go and run this, notice that it does not line up. Okay? And so the program just kind of ends. And you might go, well, wait a second, was this what I needed to do? Well, it depends upon how your program's running. Sometimes we have a program and we check for a condition, and if a condition's met, we run a couple, 3, maybe dozen lines of code, maybe more. It doesn't matter. And we just don't do anything if that condition's not met. But sometimes we want to have an alternate. What happens if the condition was not met? And so let's take a look at that. So I'm going to go after my print line. I'm going to hit the enter key. Notice that it makes it indented. But I want to use an else clause. And the else says, hey, our condition was not met. So I'm going to specify else. And I'm going to put a colon, just like I did after my if line. Notice I do not need a conditional statement here. This is assuming that our initial condition was not met. And I'll have a print statement. In this case, I'll print the name did not match what we're looking for. I'm going to save it, run it, and notice that now when my condition is not met, it goes down to the else and it prints that out. Okay. Now, my else statement could have just one line of code like I see here. It could have dozens of lines of code or anything in between. So what we put in there is based upon what's the needs of our program. And that's why it's so important to understand and know what is it my program is supposed to be doing. Now, let me take another slight change to this just to make it a little bit more complicated, but show you the power of what you can do in Python. I have a new variable called searching for. And in this case, I'm going to put Bob. And so now I'm going to check to see if first name is equal to searching for. So I have a first name that I'm testing against, and I have a searching for. This is what I'm testing for. I'm checking. Okay. So when I have a condition, I can check against two different variables. So I can check one variable against a literal value, whether it be an integer, a float, or a string, or I can check one variable against another variable. And this way, if I bring in data and it's typed in by a user, or I read it from a file, or get it off of a network drive, or an internet website I can pull down and parse. However it works, this gives me a lot of flexibility, especially as my applications get larger and larger and larger. Now, right now, first name and searching for are different. We can visually see this very, very quickly. But I'm going to test this real quick. And notice it comes up and says the name did not match what we're looking for. So let me change first name. And notice that I put in Bob all lowercase. There's no capital letters in it, but searching for does have a capital letter. I'm going to use CLS real quick to clear out my terminal screen just so it's clean and we can see what's going to happen a little bit easier. I'm going to run, and notice the results that we get in that terminal screen. It says the name did not match what we're looking for. That's because string matching inside of Python is case sensitive. Okay, so uppercase, lowercase, mixed case, that matters to Python. Now later on in some future modules, we're going to look at the strings and how we can use some built-in functions so we can check for case insensitivity. But by default, strings are case sensitive in Python. This is an important thing to remember. Okay, so that's just another example, something you can kind of take a look at. If I change this real quick to be the same, save it, and run, you're going to notice we get a different message. This is the person we're looking for. That's exactly what we want. So we've seen how we have a conditional statement, the if statement, how we can have greater than or equal to, less than or equal to, and not equal to. Those are 6 conditional operators. We've seen it with numbers. We've seen it with strings. Typically with a string, we're only going to be looking for equality or inequality. With numbers, we might be looking for any of them. We then made a slight change and looked at using a else statement to check for if our condition was not met. And we have checking conditions against a variable instead of a literal value. But let's check and see what would we do if we wanted to have a couple different values that we might change. So I'm going to once again clear out my terminal window, and I'm going to clear out my code. And what I'm going to do is I'm going to check different things at different levels or different values. Okay, so I'm once again going to create an age. And age is good because this is a good way for us to set things up and test it. Say age greater than or equal to 16. Okay, and now I'm going to have an if condition. Say if age is greater than or equal to 16, print driver's license. Now, what happens if I want to put in an else and check to see if I could do greater than or equal to 18? Well, I've got a couple options. I could say else. I could say put an if statement inside of that else. If age is greater than or equal to 18. Voter ID. And I could have an else and check to see if you're greater than or equal to 21 or 25 or 40 or any other number that we wanted to. So this just shows me that I can put in an if statement inside of the body of an if or an else clause. And this gives me a lot of flexibility. And sometimes I want to do this. But sometimes I don't want to do this because this isn't real clean. Because I could put in, if I had an else, I checked for greater than 21, and then greater than 25, and then I went on, I could be nested very, very deep. And so if I want to just be looking for the else if and kind of looking in the same chain of things, I might choose something a little bit different. So I'm going to take out this else block, and I'm going to create something that is semi-unique to Python. Now, it's not completely unique to Python. Other languages, some call it the ElIf, like Python does. Others have different names for it, but you can see it here, ElIf. And this is an else if, and it's a combination of those two. So I say else if. So my first condition was not true. I'm going to check and say, hey, well, maybe there's a second condition I can use. And let's just check, age is greater than 18. You can vote. And I can incorporate additional values. Okay, I just have a couple of examples here that you can see. Clearly, this can go on and on and on. There's no problem with that. But you might be going, well, wait a second. This is a whole lot easier than if I had to indent with every else block because I did a nested if inside of those else. And you would be absolutely correct. I've seen people do that where they get fixated on putting an if inside of an else block, and they're just doing it for something like this, and it creates a mess. Okay, there's a couple of interesting things I want to show you with this. Now, there's a couple of interesting things I want to show you, and this is very important to make sure you get your logic correct. I'm starting at low values for my age number to test against, and I'm increasing. I'm doing this because I'm checking to see if age is greater than or equal to some value. If I started at 40 and went down to 25, that may not work as well for me, okay? So I want to show you a couple quick things about this, and these are easy mistakes that you can make, okay? So I have here age is equal to 16. I'm going to run this. Notice it prints driver's license. Hey, when you're 16, that's what you care about, right? So I'm going to change this real quick to 26. Save, run. And notice that I got driver's license again. You might be thinking, well, wait a second. Shouldn't I be up here at my discounts on renting a car and car insurance? Well, yes, I should. Okay, so this was a very easy mistake. You see what happens here. I check for that low number. I just check to see if you're greater than it. Well, if you're 65, you're still greater than 16. It was true because we're doing the else if. That first one was not false, so I didn't bother checking it. Hey, I got true. I kept on going. So in a case like this, I have to be very careful. If I'm going to be checking for greater thans, I probably want to start at a high number and work down. Okay, so I would want to rewrite this. Let me just rewrite this real quick so we can fix this logic. Now, conversely, if I'm looking to see if you're under a value, I'm going to start the low numbers and go up to larger numbers. I always want to make sure I'm in a sequence, either going larger to smaller or smaller to larger. It's just depending upon, am I checking with the greater than value or less than value as to which direction I'm going to go. So let me just fix this real quick so it's a lot easier to work with. So now we have our if statements, and we start at 40 and we're going to be going down. Okay, you're greater than or equal to 40. Are you greater than 25? Are you greater than or equal to 18? Are you greater than 16? Or so it should be greater than or equal to 16. Okay, so now if I run this, first it checks, okay, if age is greater than or equal to 40. It's not. 26 is less than 40, so I'm going to come down here. Else, if age is greater than 25. Well, 26 is greater than 25, so yes, it prints out discounts on renting a car. If I made this 21, we could go through this and we could kind of, I had a former coworker, he liked to call us playing computer, when he would go and work through and see if he could figure out what the correct answer should be before he runs the program. Then he could test the program and say, did he get the right answer? Okay, so he had an expected answer and then he tested. And this is very important, I think, whenever you're working with and you're testing conditional statements. You always want to have something in mind and then test to see what happens. And so here we have age 21. Is 21 greater than or equal to 40? No, it's not. Else, if 21 is greater than 25? No, it is not. Else, if 21 is greater than or equal to 18? Yes, it is. So we should print out, you can vote. And if we go and run this, that's what we get. Okay, and so testing these things is very important. It's a very important step when you write your programming code. It's always test it. Always know what you should expect. Test for different values. See what happens. Very, very important. Okay, so these are some really important things that you want to be looking at. All right. Let's move on to our next section. We're going to look at something called a Boolean variable. So I'm going to come down to my terminal window. I'm going to type in CLS just to clear it out. And I'm going to select Control A and just hit my delete key so I can start off with some clean code. Now, every conditional statement has been generating a Boolean value. And a Boolean value is just internally to a computer. It's known as a true or false value. You can think of it as true, false, maybe yes or no if you prefer. But it's looking for, is this correct or is this incorrect? And it's the whole nature of the Boolean value is it's yes or no, 1 or 0. And computers are great at working with that type of Boolean value. So when we check to see if age was greater than or equal to 16, it was greater than or equal to 16 or it wasn't. It wasn't like, well, you're almost there. You're kind of there. You're about 16. It wasn't you look 16. It was, are you 16 or are you not? Okay. So we can take that and simplify it down into a Boolean value. And this becomes useful in computers. Because a lot of times, especially as we get into more complicated systems, we might have a function call that we're going to go out and reference, and it's going to return a true or false value to us. A perfect example of this is I can't ask the computer, is it warm outside? This warm is kind of an ambiguous term. What's warm to me might not be warm to you, and vice versa. So if I talk to someone, and I have students who are from Canada, for example, what's warm to them is going to be very different than the students I have that are from Arizona or Florida or maybe Central America, where warm is a completely different set of numbers and value ranges. In fact, it might be a combination of humidity and temperature. So we have an example here that we want to take a look at, and we're going to assume that, hey, we got a Boolean value from someplace else. And I'm going to specify is cool. I'm going to set this up equal to true. And this is how we write true inside of Python. So we'll assume that we got this from some other value. What does is cool mean? We can't define that easily. A computer can't define it. But we could go and we could maybe ask a person. They could tell us, yes, it's cool. Or maybe we use some sort of advanced weather formula to figure out, okay, based upon humidity and temperature and wind chill factor and all these different things, we calculate this out and come back with a true or false value. Okay? And so I can specify true like this, or I can specify false. Notice that both true and false start with a capital letter, but the rest is lowercase. Some languages use all lowercase, some use all uppercase. It's completely up to the language. Python chooses to start with a capital letter and make the rest lowercase. Please notice that our Boolean value is colored differently inside of Visual Studio Code compared to variable names, strings, and even numeric values. This is just a visual clue that Visual Studio Code gives us to help us know, hey, did I type this in correctly? Because if I type in false, notice that it does not color code it correctly. And not only does it not color code it correctly, it underlines it, letting me know that there is a problem. If I hover over it, it just says, hey, false isn't defined, and I can change it like this. Now, what's interesting is because it's a Boolean value, I can either check for equality or inequality. Those are my two options, okay? But inside of an if statement, I'm looking to generate a true or false value, correct? And that's what my condition does. So I can specify, I can say if is cool equals true. And I can print out a statement, hey, you should wear a jacket today. Okay? Maybe this is for like a personal assistant type of application, and it's going to send a text message, or it's going to show up on a little smart mirror or something when you're getting ready in the morning. It comes up, it checks for you, and says, hey, you know what? It's, this temperature, but it's got this wind chill factor. You know what? We're calculating you need to wear a jacket, okay? And so we're assuming there's lines of code up above that are figuring out some of the stuff for us. We're just looking at the easy part. And I can do this with an if condition, okay? But because my Boolean value already holds that true or false, I don't have to check to see if it's true. I can simply say is cool. And so let me go ahead and set that equal to true so we can print out the true statement. And notice that I don't have to do that condition because that Boolean variable is already a true or false value. So the condition test is just repetitive. And so we can make our code just a little bit smaller, a little bit faster, write, a little bit easier to read. Some people do it and you can see it like that. Now, a lot of times with a Boolean variable, you'll notice that it starts off with is. And that's a pretty common methodology to let us know that, hey, This is cool. This is hot. This is a saved document. This is an unsaved document. This is whatever. Okay? And so a lot of times we talk about an is a type of value. We're talking about a Boolean data type. And so it's just a little clue that we use as software developers to make working with it a little bit easier for us to remember. Okay? There's no rule. And if you don't put is there, no one's going to fight you on it. The computer's not going to give you a warning or an error message or anything like that. Like I said, this is just one of those little clues that you have to make working a little bit easier. Okay? The last thing we want to look at is Boolean logic. So let's look at what Boolean logic is. Boolean logic allows us to have a condition like this and another condition. So we can actually check for two conditions. Okay. All right, so I've cleared my terminal and my code window just so we can start fresh. And let's look at our last thing, where we're going to use Boolean logic. Now, Boolean logic allows us to take one condition and check it against another condition. And we have to say, okay, if either one of these conditions is true, or maybe if both of these conditions are true. So let's take a look at a simple example. We'll start with two conditions being true at the same time. So I'm going to specify here age equals 21. We've seen this before. And I have is registered. I'm going to set this equal to true. Now, you might be thinking, okay, well, what is this referencing? Well, we're going to see if someone is eligible to vote. In the United States, you have to be both 18 and registered to be able to vote. Now, if you are under 18, in some places they let you register knowing that you'll be turning 18 in a certain amount of time, and you can then, once you turn 18, you can vote in that election. And they do this sometimes because it sometimes takes a couple of weeks, or in some cases even a month or two, in order to process your registration. So you have to be both 18 or older, and you have to be registered if you want to vote. So let's write an if statement that would show that. We're going to start off just as we normally would with if. We're going to say age greater than or equal to 18. Okay, this is easy. And then I could put inside my if block, I could also say if is registered. And I can say you can vote. So notice that if you're greater than or equal to 18, you come down, then you have another if statement. And that's just, once again, that gets into that nested if statements. And if you have too many nestings, it's hard to read your code. Okay? So this is where our Boolean logic is going to help. So I eliminated that nested if statement, and I got rid of that first colon, and I'm going to specify and is registered. Okay. Now, my print statement had two indentions, and technically Python would allow it. I got rid of that one level of indentation. Okay, that just makes my code a little bit easier to read. But let's see how this reads now. We say if age is greater than or equal to 18 and is registered. So if those two things are true, it's going to print out you can vote. And notice it does. Okay? And what makes this nice is, number one, we don't have all that indentation. But second, I can put an else clause, which is going to make it also easier, so I don't have to know where do I put that else, and maybe I was true here but not true there, and that nested, and trying to keep track of how many else clauses I have. Too much work. So I can have a single else clause. Else print I want to say you are not eligible to vote. Now, the interesting thing about the and is that once it is found to be false, it quits checking everything else. So, for example, if I said my age was equal to 13, I go and run it. It doesn't bother checking the is registered. It says, oh, and says everything has to be true. I found something that was false, and it fails and goes to my else clause. Okay, so that's just kind of an interesting thing with how you can write your code. You want to write the thing that is most likely to fail, put those things first so we don't have to check it. You might say, well, those things, you have two. Well, I can say and is registered and I can have multiple conditions if I need to. So I could check to say, okay, if you're registered to vote and you live in the current state and you live in the proper district and all those types of things, I could go and have 5, 6, a dozen. And you might think, well, is that really going to happen? Will I have 5 or 6 different conditional tests? And the answer is you might. Now, it is kind of rare, but I have written code that has between 8 and 12 and statements in it. Like I said, that's rare. Usually it's 1 or 2. Occasionally you get 3. Those large ones are kind of rare, but it can happen. It's nice to know that you've got the ability to chain all those and statements together. As soon as one failed, the whole thing fails. And so you saw that with 13. If I set this equal to 18, it's going to work. If I set is registered equal to false, you're going to notice that it fails completely. Okay, you're not eligible to vote. So this is really helpful. Let's check a couple of other quick things real quick. So that's our AND operator, and it's used quite a bit. Okay, we also have another Boolean logic operator. So let me clear out my terminal window, and I'm going to clear out my code real quick. So I'm going to check to see, do you need to take your final? I'm going to say num of absences equals 1, and I'm going to say AB average is true. Okay. And so what's going to happen here is if you have someone who has a low number of absences in class, or they have a very high score to begin with, maybe we'll say they don't have to take the final. Okay. Well, we're going to use an either or. So I'm going to come here and say if number of absences is less than or equal to 2, or AB average, where it's a Boolean value, so we're just going to check to see if it's true. Print the final is optional for you. And I'll have an else here. You must take the final. Okay? So just a couple of quick, simple examples here. All right. Now, both of these conditions are true right now. And so if I look at this, it says the final is option. Well, I'm going to say, well, you know what? I was sick and I missed 3 classes. I'm going to run this again. Well, notice it still comes back to final is optional. That's because the OR is checking to see, is the first statement true? Is the second statement true? Or are they both true? If any one of those conditions is met or all of them is met, then the true block runs. The only way the else blocks runs is if all conditions are false. So it's very easy to get a true block to run in this case. Once again, you can have 2 elements with a true block, or you could have multiple OR statements. And yes, I have written code that has multiple OR statements. And in a business type environment, it might be something like, Okay, is this less than a certain dollar amount, or you have manager approval, or it's already budgeted, or it's, and we did this for an accounting approval process to try to speed up the approvals when people had to purchase things. And so if it was under a certain amount of money, you didn't have to get a manager's approval. If it was under a different amount of, or if it was already budgeted, then you didn't have to get approval because the manager already approved it when they did the budget. Or if you had a manager's approval with the process. So they didn't approve it beforehand, but now they are because it's now a new statement. So depending upon how it worked, there was like 3 or 4 different ways that it might get approved and move on to the next level. And all we had to do was say, hey, which one of these was it? And once we found something that matched, it went through. The only way it got kicked back was if none of those came in, So it was too much money. You didn't have a manager approving it. It wasn't already budgeted. Okay, then they're like, look, we're just not going to spend $100,000 because you want to. Go get someone to sign off on this. And so we tried to make it easy, but we had to be legitimate as well and had to be fiscally responsible. So yes, you can have and string along multiple OR statements. Once again, I could put this in nested blocks. So if this, else, okay, I'm going to have another if, well, maybe we're going to do it here, else, okay, maybe we're going to do it here. But that's harder to write. It's harder to maintain and manage. This is much, much easier. Now, in this case, we use a numerical condition operator as well as a Boolean value. We could have had 2 Boolean values that we were testing. We could have had 2 conditional operators we were testing. Does not matter. It's very, very flexible for us. It allows us a lot of strength. And these conditional operators are used and provide a lot of flexibility in our code to decide, do we want to run this block or not? Or do we want to run this block versus that block? Or in some cases, as you saw, where you can have multiple else if statements, you have this block, 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 which one runs? It gives you a lot of flexibility. It lets you test and check to make sure things are working. That's all very important in order to run with this process. And so those are the main things that you want to be looking at with using a conditional statement. The most popular one inside of Python is going to be your if statement. Now, in Python 3.10, they just did come out with a switch statement, which is brand new, has a lot of functionality to it, but that's not something that everyone has installed on their machines. A lot of people are still using Python 3.7, 3.8. They're still pretty stable. They're still very supported. So we didn't want to show you something that's brand new that may not work on your machine. And anything that you can do in switch, you can do with if statements, but they tend to be a lot of if statements. And so you don't see it very often because most people try not to write their code in that type of way. So that's just something, if you maybe did a little bit of reading or looking at some different things, that's something you want to keep in mind. All right, I'll look forward to seeing you in future modules.